last but not least, we're going to look at Punnet squares. And so Anna's genes, she has a brown hair gene, a blonde hair gene, mixed with Christoph genes, 2 blonde hair genes. What are the possibilities for their children? And so over here, I'm going to put Anna's genes. Okay. So they sort independently. And so when I say sort independently, that just means they're going to split up just like this. And then Christoph genes, again, they sort independently, so they're also going to split up just like this. And so what happens, okay, we went through the process of meiosis. We know how all of these end up by themselves, okay? Now, when Anna and Christoph go to have kids, Anna's going to give a gene, and Christoph's going to give a gene. And we represent it using this Punnet square. So in this box, okay, we have Anna's genes, and over here we have Christoph's genes. And so when they meet together, this big B, that would be like Anna's gene coming here, Anna's egg, meets with Christoph's sperm, boom. This baby is big B, little b. All right, now over here, that would mean this gene from Anna meets with this gene from Christoph, boom. That baby's gonna have blonde hair. All right. This box here, we have this gene from Anna, this gene from Christoph, boom. That baby's gonna have brown hair. And then one more time, in this box, we have this gene from Anna, this gene from Christoph, and boom, this kid is gonna have blonde hair. And so that's what we're doing when we set up this Punnet square the way you see it. And so here, when I fill out the Punnet square, I just bring the big B down, bring the little b over, little b down, little b over. Y'all can finish this. Y'all are experts at this by now. And so we can see 50% of their kids should have brown hair, 50% of their kids should have blonde hair. We ended up with some mutations with some pink and purple hair, but we won't mess with that. But here we go. So this is a 50% brown hair, 50% blonde hair, or a 1-to-1 ratio. Okay, so in my class I taught you it's 2-to-2 because you have 2 brown, 2 blonde. That reduces down to 1-to-1. Okay. Also, let's review here real quick a difference between genotype and phenotype. Okay. Genotype, you're going to think letters. Phenotype, you're going to think looks. So the genotype, 50% of their kids are going to be big B, small b. 50% of their kids are going to be small b, small b. For phenotype, 50% will have brown hair, 50% will have blonde hair. We'll do some more practice with that later. So let's try this example. In roses, red petals are dominant over white petals. 2 heterozygous roses are crossed. What are the genotypic and phenotypic ratios of their offspring? Now, first of all, you're going to have to know your vocab. If you don't know your vocab, you're going to be lost. So here's a reminder of your vocab. Homozygous dominant. Remember, homo means same, so both of these letters are going to be the same. Dominant means they're both going to be capital letters. And remember, a dominant trait is going to overshadow a recessive trait. All right, homozygous recessive. Remember, homo means same. Both of these letters are going to be the same. Recessive means they're going to be small letters. Heterozygous, hetero means different. So the 2 letters are going to be different, one big, one little. Genotype, those are your letters. Big B, that's the genotype. Big B, that's a genotype. Little b, genotype. This is a genotype. That's a genotype. Phenotype, that's the looks. What do they actually look like? Do they have brown hair? Do they have blonde hair? Do they have red petals? Do they have white petals? Do they have curly hair? Do they have straight hair? Whatever it is. Okay, that's phenotype. All right, so back to this problem. Let's break it down. So heterozygous, okay, that tells me that their letters are going to be different. One big, one little. I also know that red is dominant. So since red is dominant, I'm going to pick R as my letter. And so I know that I'm going to have a big R and a little r crossed with a big R and a little r because it says both of these roses are heterozygous. All right, so from there, I build my Punnet square. This is one parent. This is another. All right, so I do this. Okay, now, and remember, you saw before, I'm just moving the boxes. The big R came down, the big R came over. The little r came down, the big R came over. All right, now notice when I say genotype, I'm looking at the letters. And so for genotype, I always have three possibilities. I could have big letter, big letter, big letter, small letter, small letter, small letter. So big letter, I have one of those, 1 out of the 4, so that's 25%. Okay. Big R, little r, I have 2 of those, 2 out of 4, 50%. And then little r, 1 out of 4, that's 25%. So this is my genotype percentages. I asked for genotypic ratio. That would be a 1 to 2 to 1 ratio. 1 of the big R, 2 of the big R, little r's, and then 1 little r. Okay. Now, when I say phenotype, I want to know the looks. So I'm going to say, okay, this one, does it have red or white petals? This one has that dominant R, so this one has red petals. This one also has a dominant R, they have red petals. Dominant R, red petals. There's no big R here. So since there's no big R, this one has to have white petals. So for phenotypic percentages, 75% or 3 out of the 4 have red petals. 25%, 1 of the 4 have white petals. Now if I'm looking for a ratio, that would be 3 to 1. 3 red to 1 Let's do white. This example. The gene for curly hair is dominant over the gene for straight hair. A heterozygous father is crossed with a mother who has straight hair. Okay, so this tells me a lot, even though it looks like a little. Curly hair is dominant, so I'm going to pick big C for my curly hair. So let me designate that over here. Big C means curly hair. Little c means straight hair. Okay. Now it says the father is heterozygous. Heterozygous means different, so I'm going to have 1 big C, 1 little c. Now it says the mother has straight hair. The only way for her to have straight hair is if she doesn't have a big C. So the only possibility for the mother, if she has straight hair, is little c, little c. All right, do my Punnet square. Here's father, here's mother. Make sure you make your letters really obvious, which one's big, which one's little. Okay. All right, so for genotype, I can see, all right, these 2 out of the 4 will have curly hair, so that's 50% big C, little c. Sorry, I'm talking about genotype here. So 50% big C, little c, and then 50% little c, little c. Okay. Now for phenotype, I'm going to have 50% that have curly hair and 50% that are going to have straight hair. And if you want this in ratios, the 50-50, that's a 1-to-1 ratio. Voila.